So we're just about finished with Chapter 6. Thanks for hanging in there. I hope you've been able to take the lecture at your own pace and pause as needed and make sure you've gotten all this material down. But I want to do one more example of what we just did, sort of using the Hess's law of heat summation with formation reactions, but now without the bother of writing out all of those formation reactions. Because, I mean, imagine a large reaction, even larger than this one that I have on the board right now. That would have a lot of stuff going on that you'd have to cancel out and worry about everything dropping out. But it's going to work if you've correctly set up the formation reactions. And so we can go directly to that quote shortcut as I just showed you. So let's find the enthalpy change for this reaction now, and it has a couple of coefficients in it, and so that's why I wanted to work with this. We're taking solid calcium hydroxide, reacting it with aqueous hydrochloric acid to produce calcium chloride in the solid phase and water in the liquid phase. So I've already looked up the enthalpy of formation of each of the four compounds at work here, or in play. Be careful when you go to do this because a couple of these are in Appendix 2B multiple times, in particular HCl. HCl can be formed in the gas phase or the aqueous phase, and water. You'll see water in the liquid and the gas phase as well. So you always want to pay attention to the little letter in parentheses indicating the phase, since it's going to make a significant numerical difference. Right? But for a reaction like this and any other reaction, the enthalpy change can be found, as we just said from Hess's law, by adding up the enthalpies of formation of our products and subtracting the enthalpies of formation of our reactants. Again, we're adding the products. They're getting kicked in, their energy at least kicks in the way they're intended, because we're going to be making these things, so we're going to give off, in this case because of the negative signs, we're going to give off these amounts of energy. But the reactants, they're not being made, and that's what these energies are for. When you make these reactions, these are the corresponding energies. But we're destroying or eliminating these reactions, so now these become the cost associated with that. And that's why we need to subtract this out. It's a lot like accounting in a business, right? How much money comes in versus or minus then how much money you spent on building up your inventory and buying the things that maybe you sold. Okay? So for this reaction then, our products are the calcium chloride, negative 795.0. So that's my CaCl2, plus 2 times my water, negative 285.8. Okay? Add all that, minus then your reactants, negative 986.1 for the calcium hydroxide, plus 2 times negative 167.5. And now the nice feature of this formula is we don't have to worry, was I switching the signs? All we have to do is put the coefficient of each chemical in front of its delta H value. This minus sign takes care of the direction change that all of our reactants have undergone at once. All right? So if we add up our product amounts first, that gives us negative 1366.6 plus is what we're going to get here, negative plus 1321.1. So this equals negative 45.5 kilojoules as the energy change of this reaction up here. And that delta H now is sort of where we were actually in the first class of the semester. This now is in relation to each of these, and we can answer different questions now. Well, how much heat is evolved if only 2 grams of calcium hydroxide are used, not an entire mole? So you could now use this in a Q equals N times delta H. Or what if it was 10 grams of HCl? Keeping in mind that it's relative to 2 moles of HCl, but only 1 mole of calcium hydroxide. So we've sort of come full circle to where we were at the start of this chapter when we learned about our heats and things. But at this point, you're really well set up for the rest to do all your homework, I believe, in Mastering Chemistry. And we've wrapped up Chapter 6, and we're ready to move backwards now into Chapter 5 when we'll talk about some gas laws. So good luck with the homework, and I'll see you soon.